Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Magnifying Glass and Application of Lenses. This is part D of Refraction through Lens. So in this video we are going to solve the theory questions, right? So before watching this video, watch the concept video. Then only we will understand the questions as well as the answer, or else a few words will definitely confuses you. Without wasting any time, we'll start with our first question. First thing you need to know, whenever we are using magnified glass in this concept or theory solution or the concept video, magnifying glass is nothing but simple microscope. Simple microscope means you have to assume it as magnifying glass. So in the exam, okay, they may use magnifying glass or simple microscope. Both are same. So it is related only to convex lens. Okay, convex lens, and that is the last case of convex lens. This is what we have learnt in ray diagrams, correct? So keep all these things in mind. Okay, magnifying glass or simple microscope. When it comes to magnifying glass, it is always with respect to convex lens, and in the convex lens, the last case when the object is placed between optic center and focus, okay, optic center and the focus, we are going to get the virtual image, right? That case is nothing but the magnifying glass. So this basics we need to learn before starting our first question. Before solving the theory questions, we need to understand which are the topics are there for the syllabus and which are not. Okay, when it comes to part D of refraction through lens, many students will think the complete part D is only not there in the syllabus. So few topics are there, these are the topics are there, and these are the topics which are not there in the syllabus. Okay, first we need to identify that, then we have to learn it, then it will be easy for us, so that if it is not there in the syllabus, we don't have to focus on that and we can aram se learn the remaining things. Now our first question, what is magnifying glass? Stated two uses. So it's a very simple question. See, when it comes to these kind of questions, if you go for online solutions, okay, where they'll give you the complete big definition, that is not required. Simple definition is required, which I'm going to teach you right now, because when we go for the corrections, this is what they give us. Okay, so what is magnifying glass? Magnifying glass is a convex lens of shorter focal length, which is used to see the tiny object distinctly. This is enough. See, it's a convex lens of shorter focal length. Focal length is very small. Why we are using it? To see the tiny object distinctly. Distinctly means we are going to see the increased size of an object as an image through the magnifying glass. That's it. This is the definition, and they are asking for two uses. First one, watchmakers used to see the small parts and screws of the watch. This is the first uses. There are many uses, we can write any two. Okay, this is used as a traveling microscope, we can travel it, portable. Okay, then it is used in spectrometer. Like this, we have many applications. They are asking for two, we can write any two. In the exam, they will not ask for two, maximum they'll ask for one. So we know in physics exam, most of the questions are for 1 mark. So but you have to be very careful, or you have to learn everything based on the things which are there in the syllabus. They'll create questions. So you have to learn everything, and you have to be ready for everything. Whatever the questions they ask, you should be able to answer it with the knowledge we are going to get from the videos. Our next question, where is the object placed in reference to principal focus of a magnifying glass as to see its enlarged image? Where is the image obtained? Okay, now listen. So here we need to understand what is magnifying glass, in which the ray diagram we are going to use. Listen, very simple. In the definition we have learnt, it is based on convex lens of shorter focal length. So in one of the ray diagrams, we have this magnifying glass. What is that? Which is that ray diagram? Very simple. The last case of convex lens. The last case of convex lens, that is this one. Okay, if you know this diagram, when it comes to magnifying glass, you have to imagine this diagram only. When it comes to magnifying glass, this is the diagram, last case of convex lens. Then only you can answer the questions. Now if you know this diagram, okay, if you have seen the ray diagram video, you will know this, correct? So if you know this, you can answer this question. See, where is the object be placed in reference to principal focus of a magnifying glass? Where should be the object be placed? We know object should be placed between optic center and the focal length. Optic center and the focal length. So it is between, object is between these two, correct? That is why it has a shorter focal length. Okay, then one more question we have, where is the image be formed? Image is formed behind the object, the enlarged image, correct? Enlarged image be formed behind the object on the same side, on the same side. That's it. Our next question, write expression for the magnifying power of a simple microscope. How can it be increased? This is a very simple question. Listen, they are only asking for the expression. Based on this expression, expression means formula. Based on this formula, no one is going to ask you any numericals because it is mentioned in the scope of syllabus. See, this formula is only not there in the syllabus. Just for a reference, we are learning this question. Based on this one, no questions will be asked, no numericals will also be asked. See, expression is very simple. M is equal to 1 plus D by F. Okay, D by F. Okay, M is magnifying power. Magnifying power of what? Magnifying glass. Okay, M is equal to 1 plus D. So many students will think, what is this D? D is the diopter, power, unit of power, right? No, it is not diopter. D is the least distance for distinct vision. So that means at what distance you can see the object properly, that distance. Okay, most of the time this D will be taken as 25 centimeter. If something is given in the question, we can take that, and we know F is nothing but focal length. And there is one more question, how can it be increased? By using the shorter focal length. By using the shorter focal length. See, if focal length is inversely proportional to magnifying power, so if the focal length is minimum, magnifying power can be increased. That's it. Our next question, state two applications each of convex lens and concave lens. So here when it comes to application, they are just asking for two. We have learnt many applications in the concept video. That is why we are going to skip this question. Okay, there is no logical or twisted question, correct? It's a direct question and they are just asking two. If I name only two, you will learn only two. We have learnt everything, right? So that is important. They are just asking two. In the exam, if they ask two, you can write any two, correct? So it is in the concept video. That's why we are skipping it. Our next question, how will you differentiate between a convex and concave lens by looking at a distinct object, printed page? First, okay, they have given two options. Using those two options, how we are going to identify whether it is a convex lens or concave lens? So the question is very simple. First, you need to understand it. What do you mean by distinct object? That means using an object, okay, and a lens, we are going to create an image. Based on the nature of image, we can say which is convex and which is concave. We know in convex lens, okay, we are going to get the real and inverted. We cannot say whether it is real or inverted just by looking at it. But if it is inverted, how can we say real image? Because of the intersection. That is how we draw the ray diagram. But in the actual picture, we cannot see the intersection, right? So we can only identify if it is inverted, it is real, correct? We know that is the characteristics of a real image. If it is real, it will be inverted, and if it is inverted, it is obviously convex lens. So for a distinct one, okay, for a distinct object, if it is inverted, it is convex. If it is erect or what is the other word? Upright. Erect or upright, it is concave lens. That's it. Okay, this we have learned. This is the basics of ray diagram. Next up, printed page. Okay, now whenever you take a printed page and a lens, okay, when you go close to it, if the letters magnified, okay, in printed pages, right? Second one is printed pages. Okay, if magnified, if the letters magnified, we know it is convex. Why? Because in concave lens there is no magnified image, it is always diminished. Correct? What is the those are the natures of the concave and convex lenses which we have learnt in the basics. Correct? So in concave lens there is no magnified image, it is always diminished. So even though you go closer or it is in a proper distance, the letters on the printed pages appears to be diminished. That means the size of the letters are very small even though you are looking through the lens. So if it get magnified, that means it is convex lens. Okay, diminished, it is concave. So these are the important basics. This is what we have learnt it, right? So that's it. Our next question, draw a neat label diagram to locate the image formed by a magnifying glass. State 3 characteristics of the image. So instead of using magnifying glass, what is the another name they can use? That is simple microscope. If they use the word simple microscope, you should not get afraid of it. Now we'll go for the question. See, they are asking us to draw the ray diagram. We know magnifying glass is nothing but a convex lens of shorter focal length, and we have learned that this is the last case of the convex lens. Correct? So this is the diagram. We have learned this in the ray diagram how to draw it, and they are asking for the characteristics. The image is virtual, magnified and erect. Image is virtual, erect and magnified. That's it. Question number 2, question number 3 and question number 4 are not there in the syllabus. That is why we are going to skip it. Okay, only few concepts it is there in the syllabus. That is what we have learned before starting the theory solution. So question number 2, question number 3, question number 4, we are going to skip it as it is not there in the syllabus. Now we have completed all the theory questions from the part D. I believe you have understood everything from part A to part D. See, many students will think part A and part D are not important. Part A logical questions, part D simple questions, part B ray diagrams, part C sign conventions and numericals. Everything is important. Learn everything and go on like this after after understanding the concept video, learning how to write the answers using in the theory solutions and numericals. The remaining part is application oriented questions. Okay, that you can get the knowledge, complete knowledge of any chapter by solving the previous year paper. So if I give you previous year paper, that is of no use. It has to be chapter wise. From the chapter refraction through lens, what are the previous year questions they have asked, then only you can completely get the knowledge. So after this one, go to the previous year papers only based on this chapter, then application and logical question based on this chapter. After that, MCQs. Everything is chapter wise and all the links you can get it in the description box. Thank you.